And okay, so our topic today is what's happening in the US market, what's changing in REC's current position and products. So maybe with that, I should go back to the presentation. Now, I guess we can talk a little bit about the products. And for the viewers' benefit, we've done recently another solar conversation where we talked about REC and REC's HJT technology. So we're not going to dive too deep onto the details of the technology, but maybe we can talk a little bit about the recent market focus change in REC's US position and also the products that are relevant to that.
That's right. And I
So,
think rewinding one slide to where there's a three module side by side, this is a nice
yeah,
visual tool to explain because
yeah,
in essence, are we rediversifying our efforts to approach what we call the three major market segments. So the way that REC is segmented this, I think is similar to others, which is there's a residential market segment with its own key requirements, dominant buying motives. There is a non-resi DG segment. So, the term commercial industrial C&I to me is too narrow. There's lots of other applications within there, but certainly on the customer side of the meter. And then there's utility, which is wholesale power. And
yeah,
historically, REC, since its US entry, has targeted all three of those and been fairly diversified across all of them with different products. Although in the very beginning, large DG and residential, it was quite common to use a 60 cell product off of course, that day smaller, those were M2 cell size. You would simply have a 1,000-volt bill of material as opposed to a 600. You could use the same thing in those. But it's just been in recent years, really, since the advent of REC's heterojunction products, that the organization has doubled down on residential. Because as we first explored just with 600 megawatts of annualized capacity, then added another 400 to 500, that scale really is dwarfed by, say, the demands of the utility segment, or even some
right.
of these larger DG projects are upwards of multiple megawatts. And it just made sense for us to roll out that heterojunction product and get some fast learning and product redesign opportunities. We're already on the third or fourth revision of the design of our HJT products and moved it to a larger wafer size, basically increasing the competitiveness of this fundamentally high performing, reliable technology. That piece has always been there, but
Yeah,
what is the right form factor? What is the right packaging that the industry is looking for? So that's really been solely residential for the last 3 years, but REC's expertise with the prior products. So we followed a similar trajectory to other manufacturers, which it was all P-type multicrystalline, then in the addition of PERC technology to that, then P-type mono PERC, N-type TOPCon. We followed all of those and have really been in a search for years. We know that we're not as large as some of the big Chinese. So we simply look to exert our R&D and quality manufacturing advantages on the product design side, as well as on the commercial side with sales and sales support. And it is time now that we are able to significantly increase our capacity, that we can readdress the non-residential segment, the utility segment. Some of this will be with product that will come from the India facility when that's online, which should be towards the end of this year into next year. But in our existing Singapore facility, we are allocating some of our production space to a large DG focused product. This is a 60 cell form factor, but on a G12 wafer. So this is something that gets you around 630 watts. It is a monofacial rather than a bifacial design, because this factory was set up originally and still only to handle glass on the front side, and it needs the equipment handling is for a flexible polymer backsheet. And REC has learned through experience, it's our failing, that the optimal way to produce a bifacial product is a dual glass. And then you also change a bit of your design, which is in the search for reducing cell to module losses. So maximum module efficiency, if in a monofacial product, you would have things like potentially support bars and junction boxes sitting over the back of the cells, because in a monofacial application, that doesn't matter. If you're going to a bifacial application, you don't want to shade the back of the cells. So then you're expanding the module footprint. You're putting the J boxes in an area where there's not a cell on the other side of it. So you're basically losing module efficiency, at least from the front side, but then recouping it from the bifacial performance gain. So those will be features of the upcoming bifacial products, but there's still a lot of market opportunity for a high performing 630 watt module, monofacial with an excellent temperature coefficient, very low degradation rate,